Greetings, welcome to Raven's Roost Forge. I'm Tate, your host, and this is part 2 of our stump anvil build. Let's get started. The sledgehammer that I used for the stump anvil build actually is pretty soft, so it's going to need to be heat treated. So I'm setting up the little charcoal forge that was built in a previous video, and we're going to heat treat it. I actually had been experimenting a little bit with this forge, and so you can see there's a little bit of coal coke in there, which actually burned pretty well. And the interior of the fire pot I painted with a little refractory mortar, which made it a little harder and more durable, but it's not really necessary. Here you can see I decided to ball up a piece of the bag the charcoal came in to use for a fire starter, and it worked really well. And then I'm just using a little propane torch to actually light it up. Once you have your initial fire going, you're going to pile up your charcoal over the top of that and then crank the blower to get some air in there to really get the fire going. Initially, with the paper and the charcoal just getting started, you get a good amount of smoke, but as soon as it heats up a little bit, then the smoke really disappears to a large extent. With the mass of the anvil and the type of steel it's likely made out of, we're going to use a water quench in order to get it hard. Before I do the heat treatment, I've decided to permanently affix the spike to the base using some silver brazing wire. This step is completely unnecessary, and you'll have a perfectly serviceable anvil if it's just threaded together, but I decided to affix them permanently to add a little extra strength to that joint. In order to braze these two pieces together, we're going to need to get everything up to a bright cherry red. And since the anvil portion is so much more massive than the stake, we're going to preheat that side by placing it face down in the fire and allowing it to soak up some heat before we turn it on its side to get everything up to a cherry red. You may notice in the next scene that I'm wearing a particulate respirator. I put this on because I realized that without a chimney, this little forge gives off a lot of fine ash that you don't want to suck into your lungs. Once the anvil is hot enough that it just barely begins to glow, I'm going to mix up some of this black brazing flux and then apply it around the joint using a small wooden dowel or a metal rod. It's worth noting that in video, metal often looks hotter than it actually is in person. I could just barely see a faint glow, but it looks considerably hotter on video. This will come into play later as well when we're actually doing the heat treating, so you can't go by the color that you see on the video. Now that the flux is applied and the anvil is preheated, I'm going to turn the whole thing onto its side so that I can start heating the stake as well. In order to make sure that it heats evenly, it's going to be pretty important that you rotate it frequently to heat from all sides. It can be pretty hard to get a large piece of steel like this heated evenly in a small solid fuel forge like this. The trick is to make sure that you've got a good bed of coals underneath the item, the whole item is covered over with coals, and you rotate frequently to get the heating even. Through the magic of editing, what looks to you to be a couple of minutes actually probably took 10 to 15 minutes of cranking that blower in order to get the whole piece up to heat. Again, as mentioned, this is going to look a lot hotter than it really was. In reality, this piece was probably about an orange heat, where it looks like it's yellow hot in this frame. Anyway, once you get it up to heat, you're going to press the brazing wire against the joint and allow the heat to melt it. Capillary action will draw the metal in to form a permanent, strong joint. When the brazing is done, we're just going to leave the anvil face down in the fire to soak in the heat for just a couple of minutes while we get ready for the quench. Most sledgehammers will be made of a simple medium carbon steel that will need to be brought to a temperature that's just a little bit higher than non-magnetic in order to harden. Okay, we're ready to go into the quench. I'm going to double check the temperature using a magnet and it doesn't stick. So we go in, agitating to try to get the face to cool off quickly. The rest of the anvil is not dunked in the water because I don't want to harden the base and I don't want to risk damaging the brazed portion. It's worth noting that I probably overheated the anvil a little bit when I did the brazing, so the best practice would be to normalize before you do the heat treat. But for a piece like this, it's not likely to make a huge difference, so I went ahead and skipped that part. Okay, back to the task at hand. The face needs to be cleaned down to bare metal so that when we temper it, we can see the tempering colors. I first try to do this manually with a loose grinding disc, which doesn't really work, so you'll see in a moment I pull out the grinder to polish up the face. The base of the anvil is still a couple of 100 degrees, so I use the pliers to hold onto it while I'm doing the polishing. I don't really want the base to be cooled completely because I want to use that residual heat to get through the tempering process a little faster. Once the face is polished back down to bare metal, you're going to place it base down into the fire and then allow the heat to soak through in order to temper the face. By tempering this way, you will end up with the softest portion of steel at the base and then the hardest portion on the face, which makes for the most durable tool. The hardness I'm looking for will correspond to a deep bronze color on the face of the anvil. Pull it out and quench it when you see that color. It's easy to overshoot this step, so keep a close eye. If you do overshoot, it's not the end of the world. You either reheat treat or you just deal with the anvil that's slightly softer than you wanted. It's a little hard to see with the glare, but I got a good bronze on the face. So next I'm just going to clean off the fire scale and residual flux using a surface conditioning disc. I can't quite get into the corners with the surface conditioning disc, so I just use a stiff wire brush to get those areas. Next, I just wanted to see how well the braze locked these two pieces together, so I'm just going to put a wrench on there and then see if I could unscrew it. As you can see, even with some pretty heavy pressure, it doesn't budge. Next, I'm going to use some inexpensive hardness testing files to see if I got the hardness I was shooting for. I know this is not that hard, so I'm going to start at the lower end with HRC 45. And the HRC 45 file scratches the surface pretty easily. So then I try the lowest hardness in the set, which is HRC 40. And wouldn't you know, that scratches easily as well. So that means it didn't harden. And I think the reason why is because this may have been a mild steel mallet rather than an actual sledge. If that's the case, the only practical way to harden it will be to case harden it. So I decided to add a video to this series showing you how to do that next. But for now, we're just going to imagine that we got the hardness that we needed and move on. So I'm just going to polish the surface with a 220 polishing disc on the grinder. You don't absolutely need to do this, but you want a pretty good polished surface for when you forge. This will also get the scratches from the hardness testing files out. Of course, this step isn't necessary either. I'm just using sandpaper on a flat granite surfacing plate in order to get a better polish on the face. And that looks really nice. Unfortunately, I'm going to have to partially go through this process again after I case harden it, but that's for another video. The next thing we need to do is make sure that we've got a base for it. This actually is an old base for a striking anvil that I'm going to reuse. It's just made from a 2x6 that's been cut up and then screwed together. The construction is far from ideal. It's hollow and just uses pea gravel to increase weight. If you're building from scratch, I recommend you just get a larger 2x6 and then you cut it up into lengths and then laminate it to make a solid base. Since I already have this base, I'm going to go ahead and use it, but it's going to need some modifications in order to work. The first thing I need to do is just countersink these holes in the top so that when I remount it, the screws are sunk down into the surface. I'm going to remount the top and make sure that the screws are well below the surface because I'm going to use a hand plane to flatten it since it's badly cupped. As I said, here I'm just going to use a hand plane to flatten that surface. You can see me struggle a lot at first because I don't have a really good way to steady it until I realize I can just kind of brace it against my knee. Here I'm just checking with a straight edge to assure that it's pretty flat. This is going to get a laminated top made out of plywood because it's far too short. To get it to the right height for me to forge on, I need to add about 5.5 inches to the top. So next I'm going to cut up this strip of plywood into squares that are the right size for the base and then laminate them together into a solid block. It's a bit time consuming, but you could do all of the wood cutting that you need using a handsaw. This is a Japanese style pull saw that has a coarse side and a fine side. Make sure you have a way to support that offcut, otherwise you're going to end up splintering the edges. Once I have it cut roughly in half, I stack and then clamp the remaining pieces together so I can be more efficient by cutting through 2 pieces at once. It's absolutely doable to make all the cuts by hand. Just expect to be there for a little while. I've got power tools, so I'm going to speed up this process by making use of them. So here you can see I just stacked that plywood on top of the base and then put the anvil on top to see how high it is. A good rule of thumb is that you want your fist to touch the top of the anvil when it's hanging loosely by your side. It's actually still a little short, but that was all the wood I had easily accessible, so I'm just going to make do. I used construction adhesive in order to laminate these pieces together along with a glue spreader. I just made a zigzag pattern with a bead of glue and then spread it out with the glue spreader in order to cover the entire surface with no gaps. Once all the pieces are glued and stacked, you just need to clamp it together and allow it to dry. I wanted to get uniform clamping, so I clamped the entire perimeter including the corners, and then I stacked some heavy weight on the center to clamp that portion. Once the glue dries, you can unclamp everything and then move on to the next step. I went ahead and sanded all the surfaces. The edges, really, that's purely cosmetic, but you do want to try to make sure that the top and bottom are roughly flat. Here again, I didn't have a great way to steady this, so I just blocked it with my knee and just took it slow. After I finished with a belt sander, I hit it with a palm sander for just a couple minutes to give it a little better surface finish, which again is completely unnecessary. And then if you did everything right, you're the proud owner of a big block of wood after all that work. The next thing I did was just lay out and mark where I was going to put the holes to attach it to the base. Then I just start the holes with a small regular length drill bit, trying to keep them as vertical as possible. Follow it up with a larger aircraft length bit so I could get all the way through the block down into the base. And then attach the block to the base using lag screws. Next, I make an X in the center by going corner to corner with the straight edge, and then mark that with a center punch. Finally, I need to drill a hole that will accept the spike of the anvil. I start with a pilot hole, and then we're going to use a spade bit to drill a 5/8 hole. Since the railroad spike we used is 5/8 square, that means corner to corner it's actually wider than 5/8, so it should wedge tightly into the hole. Okay, nothing left but to mount the anvil and then give it a try. Just place the spike down in the hole and then hammer it home with a mallet. Alternatively, if you don't have a mallet, you could just place a scrap of wood over the face of the anvil and then use a regular hammer to hammer it in. I mentioned earlier in the video that I was going to need to case harden this anvil. I went ahead and did that before I mounted it, and that footage will be in the next video. And there it is, ready to go. And then I included a little teaser footage of the anvil in use. This is from an upcoming video where we'll be forging our first project. I hope you enjoyed the video and that you learned something. Don't forget to like and subscribe. Happy forging, and I'll see you next time.